We are talking about nets, not the net, not a fishing net, but we're talking about nets. What the heck is a net anyway? Well, a net is a two-dimensional representation of a three-dimensional object. What are you talking about? Well, let me show you what I'm talking about. If we have this cube, which you can see here, we can see this cube three-dimension. If I were able to go through and pull off the tape that's holding this together and unpeel it as it were, what would I have? Well, if I did that, I would have this. Ta-da! This is the net for that three-dimensional cube there. So why are we talking about nets and what's the deal anyway? Well, surface area is one thing that students should know in geometry, and surface area can be a tricky thing. They give you these formulas that are so confusing, and you get blah, 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 blah. I'm not a big formula guy anyway, so I think it's a whole lot easier to show our students how nets work, and that way they can easily figure out, if they can figure out the area of each one of these parts of the cube. Let's see, I've got 1, 2, 3, 4, 5, 6 squares. I just need to find out the area of 1 square multiplied by 6. Bingo, I've got the solution. So much easier than that complicated formula with multiple steps and order of operations issues, and it makes it really complicated. So get some of these. You can download them. I'll put some also inside the course where you can find these nets, have students build the objects, take them apart. And it's a great alternative way, and I think a whole lot easier way and a more concrete way of showing students exactly how to figure out the surface area for a three-dimensional object. So I could even use this with real life. Oh, my son loves Ritz crackers, so we've got 8,000 of these empty boxes here of the Ritz crackers. So what I could do is we could practice with the real life. I've got a rectangular prism here, rectangular solid, so I could just undo it, and let's see here. I could just figure out now the surface area that's fairly easy, because it looks to me like I've got two front sides that are equal. Just have to figure out that. I've got the bottom and the top, which are one size, and I've got two edges, which are two different sizes. So if I could figure out 2 times whatever the measurement is, the top and bottom, 2 times the side, 2 times the front and the back, I'd figure out the surface area. So have a Ritz cracker. So some nets. Let me show you a couple, and you can try to guess what they are, and then I'll tell you if you're right. I'm going to use this and hold it in front of my face, which is probably better looking than to look at my face. So you're looking at it and you're thinking, I'll bet that's a triangular prism. Ding, 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 ding. You're right. And so instead of doing the complicated formula for it, I could recognize, hey, this is 3 rectangles and 2 triangles. Easy peasy. Just have to figure out the area of one of the rectangles, multiply by 3, area of one of the triangles, multiply by 2, add those together. Easy. What else we have? We have a pyramid with a square base. Whoops, wasn't supposed to say that. You were supposed to guess. Okay. Well, I guess probably no point in you guessing now. But see, this is what it would look if we took this pyramid and unfolded it. If you were, you can see, just I would have to take these and bring them up to the top. So the base is a square. The 4 triangles make up the side. Again, it's a lot easier to see what the surface area would be. Figuring out the surface area of the 1 square, figuring out the surface area of the 4 triangles, adding them together. But wait, there's more. Try to guess what this is. Hey, you probably guessed this is a cylinder. If I was able to cut that back and put it together, and indeed it would be. Once again, boy, that formula for the cylinder complicated for the surface area, but hey, here it's easy. We've got 2 circles, count them 2. We've got 1 rectangle, count them 1. Add those together, we've got our surface area for this. So a great alternate method for finding surface area is to use nets. Go to the net. If you like formulas, go for it. Your students may or may not like formulas, and I just really think using nets is a heck of a lot easier than going through the complicated deal with the formula. So give it a try. Let us know how it goes, and try not to get caught in the net.